Well, hi, good morning. Thanks so much for joining me here in my shop on what is going to be another beautiful day here in Aurelia. It's May 25th now. Took the day off yesterday, wasn't in here. Okay, what's the story here? The story is this radio doesn't work. There's something obviously wrong with it. It has some pretty powerful symptoms, and I can't sort out where the problem is. Now, let me start out by saying, one of you, maybe you who are watching this right now, maybe on a previous video about this radio I've been working on, maybe you've nailed the problem and wrote a comment, and it's on the video, and if I were to read it, I would know exactly what to do to fix this radio. But for some strange reason, I don't read those comments. So, if that's the case, then I don't want to really apologize. It is my plan to get through this on my own. There was a time earlier on in my doing this on video where I did read all the comments, and what I won't go into the details about it. It isn't about bad comments that hurt me or anything like that. It's just the time and the volume of them, and that. And these are technical videos, technical comments. They require technical replies. Takes too much time, all that kind of stuff. It's all in the past. All those comments are in the past for me, right? Because I'm here with the radio right now, and no one's going to watch this video for at least a few hours, or maybe even not till tomorrow. That's in the past already for me. So I'm sort of apologizing if you put a comment out there and you turn on the video and oh my God, he hasn't done it yet. What is his problem? My problem is that I do this kind of work for a lot of reasons. And for all that to work out for me, I kind of gotta continue to kind of work on my own here and not become a slave to YouTube comments. Whoops. Okay. Now enough said about that. What about this radio? So I've pretty much done everything I can think of, with what I have in hand, with my understanding of it and all that, and I've gotten nowhere. Literally nowhere with this. So I've been barking up the wrong tree this whole time. Well, obviously I have been barking up. Maybe I'm on the wrong branch. Maybe I'm on the right tree but the wrong branch. There is one change here which I haven't done yet, which I will do now. I think it's very minor. It's not likely to help the situation out, but this capacitor, which I mentioned before, is down in this part of the radio. I replaced with a replacement little guy right up here in this part of the radio, and just maybe that's a mistake. So it's a fairly easy thing for me to relocate this from up here down into this area, right down in this zone here. At least it'll be down here, same place where this original one was. Maybe somehow that's influencing this. I have to eliminate that as a possibility before I do anything more. Okay, let's turn it on for another disappointment. Here we go. It's really stiffened up. Okay. Yeah. There we are. I've got almost no regular volume control movement now. Almost the whole thing is taken up with this problem. When I had the volume control in here, a 5 megohm volume control, the problem was contained in a smaller part of the volume control. Actually, it's about 80% of the volume control. Shoot. Well, that didn't do anything, just as I expected. That I had to do that, just to know it wouldn't. Now, from here, I think what I want to do is a lot of signal tracing and stuff like that. I had another idea, come to think of it, and I have thought of it, and that is to make a killer tool. Literally, the killer tool will be a capacitor and a clip lead, and a stick. Okay, I'm going to put together my killer tool here. Okay, there it is, my latest instrument, the snuffer. That's nothing more than a capacitor, 0.05 capacitor. And I'm going to clip one side to the chassis, and the other side I'm going to kill circuits with. See, the lead from the capacitor is just protruding past the little stick here. And we are going to go in and we're going to try to find out where in this radio you can snuff out that oscillation. Let's just get it barely going here. All over the volume control, of course, because we're hearing it. And that's the actual volume control output right here. That goes through a capacitor, the other side is here. Well, isn't that interesting? You can hear the charge on the capacitor. Oh, it can't be much of a charge, can it? Yeah, I guess you could have a charge on you know, this part of the capacitor. I'm just moving. Never mind. So in a sense, I'm adding a capacitor after a capacitor. That really wipes it out. Okay, let's go wandering off now. There could be some loud pops while I'm doing this, by the way. Could have sworn I heard the pitch dip there at first. Let's discharge this. So it took some time for this to charge. During that time I pulled down a voltage, and what was it? It's a screen voltage. That orange wire, I'm pretty sure, is the screen circuit. Why was I suspicious about the screen circuit before? I kind of was. Well, let's just poke around here. Stupid things. Things that shouldn't matter. Things that shouldn't matter. This might. Whoa. So what's happening here? I'm finding out I touch all kinds of places. It has an effect on this sound. That's not terribly surprising. Is it leading me anywhere? I don't know. Keep going. I just want to stay away from the rectifier tube. I think might be a good idea. That's that guy right there. So we do this in a little more of an order. Think about where this must be. Then I pulled out all these tubes except for the audio ones, and that's when the sound disappeared. You had to get to the audio tubes. The oscillation can operate with almost all the tubes pulled out. Isn't that what I found? Wow. So that's the cathode. No, it isn't. This is the signal coming from the volume control, reaching the grid of the preamp, if you like, the combination amplifier detector tube. And this is the resistor that's the leak resistor on the grid. That seems to knock it out really easily. Is this the right size? So this looks like a 0.05. Is this the right size? So that's this guy, C33. C33. 0.05. I touched something and didn't do anything. That's different. So that's the cathode resistor on the output tube, and this is the bypass. Great big capacitor here anyway, so I mean compared to this. So let's just go right to the output tube. Is there anything on the output tube that's involved in this? There's the output tube. Again, there's going to be some pops, probably. Yeah, how do you like that? So you can kill it at the output tube. That means the output tube is an active part of this. Is the output tube the active? Is it the active part? Something going on down here. So touch that. Just drained it out. Well, didn't drain it right out, did it? Just weakened it a little bit. Oh, that just knocked it right out. Comes back slowly too. Why doesn't it just come back like that? There's some voltage building up. I can't drain DC with this, really. I guess I could depress it a little bit. Take a high impedance circuit, stick this capacitor in, it's going to yank the voltage down, and then it's going to come up again with this in place, if that's what it is. Doesn't come back. That's the other side of the same resistor there. Come a little closer. But don't look over there. I sort of thought this idea, but maybe I didn't think about it really hard. So it's having the effect I expected, but it's having it all over the place. Hear this discharge, but didn't come out of the radio speaker. That's probably a ground. Yeah, that's a ground terminal I discharged too. So there are terminals that it doesn't have any effect. Oh, if we stick with the output tube, output tube down here, where we found this one. the others. This tube is not in all the way. Oh, those are all grounded. Makes a small change there. Snuffs it there. What are those two? On the output tube, that is pins 3 and 5. 3 and 5 on the output tube. 3 and 5 on the 6V6. 3 and 5. There's TUV. 3 and 5. 6V6. 3 is the plate. Surprise, 5 is the grid. I mean, so we can hear the oscillation coming out of the speaker. So the oscillation signal must be reaching the grid of the output tube. Doesn't mean it's using the output tube to generate the oscillation though. It just means it's present on the grid. It's getting to the grid. But it could be the output tube is what's driving the oscillation. So that tube seems quite sensitive if I tap on the grid or the plate. It just makes perfect sense in a way. What about the tube feeding it? What about the tube feeding it? So the tube feeding it is a what? 6SQ7. So we got 6SQ7. Just taking a look. Grid 2, plate 6. 2 and 6. 2 and 6. So that would be this tube here. 2 and 6. Where's the key? The shadows are just hiding it from me. I can feel it. Yeah, it's right there. 1. This is 2. Two, 3, 4, 5, 6. This is 6. Now these are all the others. That's a ground. That's a ground. So only 2 pins are affected. 2 and 6. Pretty sure I pulled that tube out and the sound went away, and I realized, or I accepted, that that tube was definitely part of the picture. There could be these 2 tubes in series, both of them amplifying the oscillation in some weird way. I haven't learned too much, except let's go to the tube that the IF tube. The IF tube is the next tube up, and just because you know, I'm crazy if I think I know what I'm doing 100%, ever. So there's always room for something to show up that I never imagined. So let's go see if that's the case with V3. V3. It's a 6SK7. Let's just figure out where the grid and the plate are. 6SK7. And what I'm expecting here is it won't snuff out, because I pulled this tube out and the oscillation continued. 6SK7, grid on 4. plate on 8. Grid plate 4 and 8. Okay, 4 and 8, and the correct tube is the one that's in between the. It's right up there, way up there. What did I say? 2 and 8. 2 and 8, 3 and 8, something in 8. 8 was the plate. I remember that little rhyme there. So, okay, here's 8. Nothing. Let's go around. Those are all grounded. No effect. Okay. There we are. No effect. I think that really does clarify that the oscillation has to be related to the 2 audio tubes, something I already knew from pulling all the tubes out. This is interesting. You can go right after the grid and the plate. Now, how does this help me? So if I look at the circuit that involves the grids and the plates of those 2 tubes, study the circuit, maybe verify the components. I haven't made there isn't a mistake in here. I haven't made a mistake in some way in that circuit, and in there could be a defective component. You know, I tend to leave the little capacitors in. Maybe one of the little ones is in there and is a bad guy. Okay, I'm gonna stop the video and study for a little bit. Okay, it's just been a few minutes now. The oscillation effect is a motorboating. Motorboating is often related to the AVC. The AVC has a time constant in its circuit that is a little bit slow, and so you can get that motorboating thing happening. That, I believe, is the capacitor on the AVC system right there, C38. And would it be the case then that if I follow the AVC line even up into a tube that I now think is not part of the oscillating problem, if I null this line ahead of that resistor, yeah, I'm not going to bother with that. If we look at the detector tube, this is a split detector tube in the sense that one side's doing the audio, one diode's doing the audio, the other diode is providing the AVC voltage. That's the guy maybe that is behaving weird. It's got a couple of resistors here, one that goes to the ground bus, the other one goes to the AVC line. That's actually conveying the AVC voltage. We should check both those resistors, R14 and R15. R14, R15. Where are you? R14. R16. Hello. There, R14. It's just really written really. Can you see it? Right there. Right by the big C36. Which is not there. Oh, this was the confusion again about these capacitor sizes. Too. I never really fully investigated that. 36 and 28. And C38. 38, 28, 36. So one of them is that one. That's 38. 28 now is this guy I just put in. We're relocated. 36 is who? Who? 36 is the... What is 36 doing? Is that the bypass? 36. 36. 39. 36. No, 36 was the tie from here to here. C36. Right, that's this one. That's the guy you just put in. The 4. tie ties the plate here to the plate here. Electrolytic. That's kind of weird. Wait a minute. Whoa, whoa. No, 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 no. Got my eye in the wrong spot. Up here, up here. Down here. That's a ground. So it's just one side ground. It's just a filter on here. Wow. C36. It's definitely 4. Is that too small to do the job? Is that what's happened? The job would be to quiet things way up here. But the oscillation is working this way. It's involved in the volume control. It's involved in the volume control. Volume control in this radio has nothing to do with AVC. Well, probably not completely true. Well, I don't know about that. So I'm going to check these components in here as best I can and verify their size and stuff like that. Okay, so maybe this tube is implicated, the detector tube, and I really didn't try snuffing it. So I'm going to take my snuffer. What can we snuff up here? Can we snuff anything? Let's try this blue wire here. No. Oh. No. Oh. That changed it a lot. That too. Those pins are grounded. So these two up here with these two resistors, brown, black, orange, I'm not sure what this one is. Which way is it going? Orange, purple, 370K, and the other one is 370K, and the other one would be 300, something like that, on the detector tube. Oh, which pins are those? Let's go that way. So those pins are pins number 8, 7, 6, and 5. 6 and 5, and the 6 SQ7. 6 and 5. Did I did something wrong before? 6. Something doesn't seem to be adding up just now. Let's carry on. I got the detector tube in the wrong spot or something. I don't know. Okay, 6 and 5 is one of the detectors and the plate. One diode. And the other diode is 3. 3. No, look carefully. 4 and 5 are the two. Yeah, 4 and 5. Why do you look at those diagrams so carefully? So 4 and 5. 4 and 5. So that's 8, 7, 6, 5, and 4. 4 doesn't do anything. These two do exactly the same thing. These two. This 8, 7, 6, and 5 seem to do the same thing. Why would that be? 6 and 5 seem to behave the same way. 6 and 5. Well, one is the plate and the other is the... They act the same way. The same way. How does that work? 6 and 5. So the plate and touching one of these two diodes acts kind of the same way. Pourquoi? So this plate connected by capacitor back to here. Did I see that right? I didn't see that right. Did I? Yeah. One diode's connected. It's not connected back. It's getting its... Yeah, that's right. I realized this before. The audio part's coming out of here. But the AVC, they're taking it off early back here. Well, I can't see any reason why they would, why things work the way they work, but one diode knocks it out and the other one doesn't. Let's try that again, just to be. One diode knocks it right out, and the other one not so much. 6SQ. I have to check again. Never rely on my memory anymore. 4 and 5. 4 and 5 are the two diodes. 4 and 5. Snuffer tool, please. 4 and 5. Way up here. So this would be 1, 2, 3, 4, and 5. I didn't do anything. Oh, I'm in the wrong. That's it. That's it. That's my mistake, for crying out loud. 1, 2, 3, 4. 5. 5 affects it. 4 doesn't. Is that really 4? No, it's, yeah. 1, 2, 3, yeah, definitely 4. 4 doing nothing. 4 has got the orange wire on it. It already has a capacitor going to ground right here. So one side is not, so which side's which? So there's a resistor going to one of these two terminals. And that resistor is the 30, looks like 37, looks like 370. The 370 resistor on the detector tube. On one of the diodes of the detector tube. So 370 is starting by our resistor list here. There's a 370. Is that the only list right here? What's that? What's that? Is that a 270? What's happening here? You know what? I'm going to put this on the computer screen. I'm having trouble reading it myself. Okay, here we are. Now we're looking for a 370. I see 270. That's 270 ohms. A 470. 470. Another 470. Another 470. Why am I thinking that I've got a there? I'm looking at the resistor again. Well, you know what? It could be, it's yellow, purple. Yeah, it's yellow, purple, orange. That's what it is. So that's 47K. 47K. How many of those we got? One here. Only one 47K. Okay, so that's R5. Find R5 around here somewhere. R5. Whoa. Wait, whoa. R5's way over here. 57K. R5. I'm looking for a resistor hooked up here. It's got to be either R14, R15. Well, that's it. It's got to be R14 or R15. R14, they're both 1 meg. Okay, something's going terribly wrong here. Am I looking at the wrong tube? Am I? Holy smokes. What's happening here? That's the tube with the grid cap. That's the 6K8, Jim. You boobed it up. You're boobing it up. You're mixing up the mixer tube with the detector tube in your head. The detector tube is located below the plate, Jim. The detector tube is the first amplifier tube. Jimmy, what's happened to your brain? Okay, so we're up here. What tube are we on up here? We're on the 6K8. And I'm discovering, so I am trying to find things. So wandering around and stumbling is valid, completely valid. That really affects it. Way back at the mixer. Yeah, there could be two or three feedback, 2 or 3 circuits causing this effect. They're all in on it. They're all in on it. It's a gang up. It's a gang up. The tubes are ganging up on me. Okay, well, let's run with this. Since I now know enough to realize what I'm looking at, that is 6K8. Okay. What can we find out about a 6K8 here? And the pin I'm nulling is gain 4. Pin 4 is a killer. Pin 4, the screens. The screens. The screens are carrying this oscillation around the radio, and it's finding its way into everything. The screens. So the screens are not supposed to do that. The screen circuit, a shared supply, of course, coming from one B+ power supply, and somehow they got to feed this wire to a bunch of tubes, but not have signals travel on them inappropriately. So, for instance, the screen here. Oh, this is hard to look at. Well, let's go back on that. Yeah, back on the computer screen here. Okay, so we want to pick a screen circuit. Here we are. That's a screen, and we'll follow this wire downwards to C7. Okay, so C7 is trying to do what I'm doing with that stick and capacitor. C7, how big is C7? C7, 0.1, it's a biggie. Is that not in the right place? Is it not in there? C7. Is it missing? So we can find the screen V1 and look for a big tube on it. And I think they use orange wire. So we go screen of V1. Hey Jim, which one's V1 now? V1's gotta be that. Screen of V1. V1 is a 6SK7. Can't remember. Wouldn't try anyway. 6SK7. Screen is 6. Look at pin 6. 6. So there's the nubbin, 876. So all the orange wires, and there's the capacitor I mentioned. How can you have an effect? What did you do wrong here? You got onto the wrong thing. It's not a screen. Wait. Eight, 7, 6, 5. What is 5 on the 6K8? I'm going around in circles here. 6K8. 5 on the 6K8. Pin 5 is the grid for both the mixer side and the oscillator side. Is this an oscillator out of control? So when I hit pin 5, I'm nulling both grids here on both sides of this two-part tube. Sorry, they're not holding this up. Have the grid cap. Well, that's the signal coming in that shouldn't do anything. What if I knock out the oscillator? Well, I am knocking out the oscillator. When I hit pin 5, I'm killing the oscillator. Eight, 7, 6, 5. And if we hit the top grid on the tube, it shouldn't really make any difference. Here we go. No, that doesn't make any difference. So now we've got this motorboating kind of touching the oscillator circuit, touching the detector circuit. It seems to be boosted by the first audio amp. It would have to come out, if that's the case, if the first audio amp is doing this and it's feeding all the way back, how can that possibly happen? It can't feed back to earlier stages, can it? I mean, the audio is kind of trapped up in here, kind of, isn't it? Sort of like that. And I never did. All these ideas I never did fulfill. I got to do them. Painstaking component checks. Okay, well, maybe I found something here. Seems to be a part I cannot locate. So I'm going to go over the process with you, and we will see. Let's start with the schematic. A little hard to see here on the sheet, but coming down out of this transformer is a resistor which ties to the negative bus, and paralleling it is a capacitor, ties to the negative terminal here. C27 R7. We go R7. We say, well, where is R7? In this diagram, R7 is shown right there. And right next to it is the capacitor. Right there is right up in here. So we're going to look up in there. We're going to try to find that capacitor. First, we're going to find R7. R7 is how much? 470K. Okay, now the radio's switched off, so I can stick this camera in there and we will take a look. What do you think? Now, doesn't that look like 470K there? Sure. And there you see the transformer, and you see a wire coming up and connecting to it here. That's definitely the resistor. Now there's supposed to be a capacitor paralleling that. Where? And so, oh, it's on the other end of this cable. I mean, pictorially, it's showing right where you're looking, in this gap, as if there should be another component. Now, does it look like I fooled with these terminals at any time? I don't think I ever touched this part of the radio, though. So we follow this cable. It's a little tough following it along here, because there's another one just like it. It's the closer one. It's all the way around. It's now in the back. The conductive wire comes up into my favorite place, into this switch. Now, is there supposed to be a capacitor stuck under here? Well, all I can say is, I mean, it's pretty clear on here. There should be a capacitor across R7. And that capacitor should be 100, was it a C27? C27, 100 picofarads. I'm sticking one in. Okay. Hope light is back on again. Okay, I'm going to stick that capacitor in there. We'll see what happens. Okay, missing capacitor. I have no idea how that could be the case, that a capacitor could be missing. Sure looked like I never did anything in that area of the radio. I checked the other components. They're all right location and right value. Here we go. I am prepared for disappointment. There's no antenna, so the radio should be quiet. Yeah, here we are. No difference whatsoever. I had a lot of trouble getting that capacitor in there. Let me just poke it a bit. No. So one side is grounded. The other side doesn't make any difference. I ground it. That's kind of weird, isn't it? Kind of odd. You can ground something like that and not have any difference. That's really weird. What does anybody think this is, actually? Wow. What's with that old part right there? And investigate that. Yes, what is that part? Well, I think it's a capacitor. I have trouble identifying those parts. They look like a dog bone resistor, kinda. That has got to be, that should be C35 is what that should be, I think, based on looking at this diagram. It's the only C running this way. C35 could be this guy. No, that's C33. C35. C35 is how big? $100 picofarad again. that 100 picofarad? What is that? Anyway. Well, we can put an ohmmeter across it and find out if it's a resistor. Or find out it's a shorted capacitor and not know it. It's going from here down to here. It's a long journey. What happened there? A meter. Oh, everybody's against me today. It's definitely not a short there. What's all that? Well, what happened there? Bad contacts. 240,000 ohms between those points. Well, I can cut it out and I can stick a capacitor in there in its place and find out. Let me just put a closer camera, close-up shot of it here. This is what I'm talking about. This guy. Oh, I thought he was... Oh yeah, it's hollow. You know, I have a lot of trouble identifying these things for sure. Well, nothing. Well, you know what I can do? I can do it by checking which terminals it's connected to. So, down here on the output tube, appears to be connected. You can see a bluish wire there. That's coming from the output transformer, and that would be pin number. Always hiding from me, are you, Mr. Key? There it is. So that's 1, 2, 3, 4. I think it's pin 4 on the output tube. Pin 4 on the output tube. Pin 4. Pin 4. 6V6. What is pin 4 on a 6V6? Pin 4, screen again. Pin 4 is a screen. Okay, so if we take and look at this, here, let's look on with the close-up camera here. So we're looking at output tube, screen. Well, this is miles from where I was. Wait a minute, no, that's a different one I did. What? Appear to have just totally lost my mind here. I've lost everything. I can't remember any of it. What am I doing? Who am I? Where am I? Why am I here? What day of the week is it, for crying out loud? I just sort of lost everything. Let me just recoup here. Okay, this is just a little bit interesting then. The capacitor I'm wondering about is tied right between the plate of the first audio amp and the output tube. And it's right right there. C35. Here's what gets interesting. 100 picofarad, 2000 volt tube, or 2000 volt capacitor. 2000 volts? What's going on there? Wow. Okay, so I don't think I got a 2000 volt 100 picofarad. What do you do about that? 2000 volts. What are they concerned about? Some wild oscillation in there? I don't know. I gotta think about replacing that capacitor. Okay, let's give this a try. I'm gonna measure the supposed capacitor without taking it out. So what it's saying there, it says no unknown or damaged part. No part, an unknown part, or a damaged part. No part. I mean, no capacitance. So maybe it's an open capacitor. An open 2000 volt capacitor. What am I going to do about that? 2000 volts between the plates of two tubes. What could possibly go on there? I mean, the only thing that can go on there is a resonance circuit of some sort with where the current and voltage are separated out quite a bit, you know, phase-wise, and the result is you can build up a huge voltage. How that happens there, I got no idea, but obviously they didn't put that in there for fun. A 2000 volt. Well, I'm going to look. See, maybe I've got one somewhere hidden here. And what size is it? It was 100 picofarad, $2,000. Yeah, what to do about it? This is the potential replacement capacitor here. Just checking it. So 105 picofarads. 2000 volts between the plates of two tubes. Now, wouldn't that result in that high voltage being in the tube itself in some way? Stressing the tube? 2000 volts is going to leap through almost any tube, I would think. So the rule of thumb on voltage, electrical pressure, is below 600 volts. Electricity will not jump the smallest gap, the smallest air gap you can create. That's a rule of thumb, right? I mean, nothing's absolutely precise like that, but that's why in electrical systems there's a limit, usually around 600 volts. So it might be 700, it might be 550, but you'll see there's electric systems that are designed right around the 600 volt. That's as high as you dare go without running into this problem of leaping electricity. So, and of course, it doesn't take too much voltage to push current over any surface. Any dirty surface will carry current, and just like a resistor. So you don't need thousands of volts to get over a surface. 2000 volts, I just don't get it. Is there some startup moment in there? I don't know. I don't know. Doesn't add up to me at all. So I'm going to remove that. I'm going to stick this 530 in there. I mean, if this thing goes pop, which I highly doubt, maybe it's an occasional thing. You know, maybe they're worried about a bolt of lightning coming down and just hitting that particular spot in the radio. And I don't know. What were those engineers thinking? You know what probably happened? I bet you the guy who designed this radio is busy working at his desk, and a warehouse manager comes up and goes, John, you know those 2000 or those 1000 2000 volt capacitors we ordered for that other project? Yeah, we're not going ahead with that project. Do you think you can use up those capacitors in your project? Sure. I got a perfect spot for them. 2000 volt? No, I don't need the 2000 volts, but it won't hurt. I'm going to put it in there. And then, you know, 60 years later, a guy like me standing here scratching his head. Yeah, that's a great story, but it's probably not true. The fact is you probably do need a very high voltage capacitor in there for reasons I don't fully understand. So I'm going to put the undersized one in there. We'll see if it makes any difference anyway. Plus I can test that capacitor when it's taken out. Okay, Okay, I nipped it out. I can't wait. I gotta see what the story is with it. Funny looking thing. Oh, it's not really hollow. It's semi-hollow. Okay, what do you say this time? Oh, this time it's the capacitor. It's 91 picofarads and it's perfectly fine. Oh, now what do I do? Put it back in. Dummy, I know I should have just cut one lead off and tested it, not cut both leads off. Double the problem now. Put it back in. Put it back in. I think so. I've decided to give it a leakage test here, which I'm quite certain it's going to pass, but while it's out and I can do these things, why not? Okay, it's a 2000 volt capacitor. Can you take 50 volts? Watch the eye. Oh! 450. Perfectly fine. Capacitor, there's nothing wrong here at all. Oh. Don't think it's going to hold much charge. Charge would have been dissipated quickly. A little tiny capacitor. Oh, I made a big mistake cutting that out. Well, is it really a mistake? It's just another step along the way, or essentially removing every last component and seeing what's wrong with it. Probably find out what's wrong with me. That's really what's going on here. I don't think this is soldering. The wire's got too much no, it seems okay. Okay, well, we have to test the radio now to see if it still works. That's what we got to do. That's kind of a curious arrangement here too. That was something I did some time ago. Let's investigate this arrangement here. All right, another one of these can't quite get there. That's a well, that doesn't look quite right. It looks like brown. I don't know what that is. So it's on the output transformer. So here's the output transformer, and we're looking for a resistor. Could it be R16? It's tied straight to a tube pin. Straight to a tube pin. This resistor essentially is straight to a tube pin. Right down here, right into there. Oh, it's the screen again. Okay, so that is probably R16. Oh, R16. Well, 470,000 ohms. 470,000 ohms. R16. Oh, I don't think that's R16. Okay, so is there another R we can get to? R11. R11 is not tied direct. R11, yeah, could be. You can see it that way. What's R11? R11, 22,000 ohms. Boy, that does not look like it's got an orange third band on it. It looks like a black third band. So what little tiny resistors are there in this radio? K, 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 M, 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 K, 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 270. But that's the cathode resistor, R19. R19. Wait a second. Wait a second. Is that 19? Okay, so hard looking at this. Let's look at it on the screen here. So now, where in the world am I? So I'm one of the terminals of the output transformer. Is it on the secondary or primary? I cannot tell. It's just on a terminal. Yeah, I can't tell if it's. There's no wiring diagram for that guy, I don't think. So we'll just follow him along here. Is there a resistor on this wire? Wow. This way? No. 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 Okay. Obviously, it'll go up this way. No. Capacitor. And this one just goes to ground. Come back. No. This is the only resistor. That sure looks like 18 to me. Here's 19. R19. R18. R18. Oh! 1.5K 2-watt wire wound. Well, that's far from what's in there. Well, what's this actually doing? Oh my gosh, it's part of this filter. No, it's not a filter, is it? What is going on there? So this is a negative terminal. They could have shown these wires going all the way down to here. It would be more pictorially better than what they've done here. Could that, if that's wrong, could that be a problem? Let's just double check everything again. R18, 1.5 k ohm 2-watt wire wound. That's certainly not what's there. 1.5 k, 1500 ohms. Okay, what is there? 1500 ohms, eh? Let's see. And there's no way that's 15. Whoops. 1500 ohms. What can I do with this meter? The lazy meter. You know, you have to tell this thing what you're hooking it up to. You just hook it up, and it figures it out for you. It thinks it's a capacitor. Oh, that's not very good. Tell me this resistor's open? It can't do it. Look at. Well, there could be a capacitor somehow associated with this circuit. That didn't work very well. Okay, let's go back to the tried and true regular style meter here. Check the meter. Check the resistor. It's 1.5K. So that's got to be brown, green, and orange. You see its colors? This resistor is overheating for sure. Wire wound. Now they're specifying wire wound. I stuck a carbon. What I think is a carbon. You can see it's a little bit of heat effect here. Let's look at it closely, just for fun. That's a 1-watt resistor, and pretty sure at the time I put it in, I thought these were good for 2 watts. So he's been cooking up a little bit. It tolerated it. But the colors are just shot. Let's put in the wire wound resistor. Maybe there's some need for the winding. I can't imagine that, but let's do it. Okay, I will do it. Okie doke. We're ready again. Let's try this baby out, and I think this is going to be the end for today, for sure. Okay, volume is up a little bit. And away we go. Once again. Come on, baby. Hopefully the problem is so obscure that when I find it, no one's going to say, you see, you should have known that all along. This would be one of those. Not making much sound yet. Ah! Well, there we go. Maybe I'm going to have to use this as a musical instrument rather than a radio. Okay, I think that's it for today. Well, I've eliminated a few things, so that's good. I'll just keep eliminating everything, one thing at a time. So I'm going outside to enjoy another day. Today they're saying the temperature will reach 30 degrees C, which is unusually hot for this time of year. Very hot. So I'm looking forward to that. See you.